We're going to look at finding the probability of two events happening. So finding the probability of two things. So when outcome of one event doesn't affect the outcome of a second, we'll say they're independent. But if the outcome of one event does affect the outcome of the other, then they would be dependent upon each other. So we have these two types of events, either independent or dependent events. So in example one, it just wants us to identify whether the following would be independent or dependent. We're not finding the probability of anything, just would they be independent or dependent of one another. So if you roll a number cube, then toss a coin. They're two separate, completely different things, so they wouldn't affect each other if you were finding the probability of them. So these are independent of one another. But it says, okay, well, what if you pick a marble from a bag, you don't replace it, then you pick a second marble from the bag. If you guys are trying to find the probability, depending on what that first marble is, it's going to change the whole probability of what that second marble could be that you pick. So these two events would be dependent of one another. So it says list an example of independent and two dependent events. You could list anything, just the two that I came up with. Two independent things could be spinning a spinner and then picking a card. Those have nothing to do with each other. You can find the probability of both, but they don't affect each other. So something that would be dependent is, say you guys are finding the probability of picking an M&M out of the bag. Well, if you picked one out, ate it, and then you're finding the probability of the second one you picked, it would be dependent upon what that first one was. So there's two examples. You guys could pick anything, write something else down if you want. In example 2, it just wants us again to identify if they are independent or dependent. So a month is selected at random, and then a number from 1 to 30 is selected. Not from that month, just random number. So they would be independent. A month is selected at random, then a day from that month is selected. Well, depending on what month you pick is going to depend on how many days there are. So these are definitely dependent upon one another. A letter of the alphabet is selected at random, and then one of the remaining letters is selected at random. That would be dependent because the second one is dependent upon what that first one would have been. The color of a car is selected at random, and then the type of transmission is selected. They have nothing to do with one another. It doesn't matter what color your car is to then pick a transmission for. You and your friends select a restaurant for lunch, then you select your meals from the menu. Of course, that's dependent. The type of menu or the menu you're looking at is dependent upon what restaurant you went to. A Chinese restaurant is going to look a lot different than a diner restaurant. So let's do 1 and 2 here. So number 1 says, as part of a board game, you need to spin the spinner on the right there, which is divided into equal parts. So find the probability that you would get a 25 on your first spin and a 50 on your second spin. So how many 25s are there? 1 here and here. And there's 8 total sections. So the probability of getting a 25, not a 20, is 2 out of 8. And if it's two events, this and that, that's when we are multiplying. If it's one or the other, like we've done in the past, that's where you add. But if you're finding the event probability of two events, or more than one, I guess I should say, we multiply these together. So the probability of 25 is 2 out of 8, and then the probability of getting a 50, there's just 1 50. So then 1 out of 8. So remember, we multiply fractions, we multiply straight across. So we get 2 out of 64, which reduces to 1 over 32, or 1 out of 32. Which would be 3.1%. Okay, so number 2 says a bowl contains 36 green grapes and 14 purple grapes. So 36 and 14 is 50 total. says you randomly choose a grape, eat it, and then randomly choose another one. So find the probability that the first grape is green and the second one is green. So you get a green and a green. Well, the first green grape, I guess, that you're going to pick, there's 36 in the bag out of 50. So that first probability is getting 36 out of 50 for the first green one. Okay, and then the second one. So what's the probability of the second one being green? Well, if you're saying you picked a green one, there aren't 36 left in the bag. There would now be 35 left. And if you had just picked one out, there's not 50 there's not 50 grapes left in there to choose from. There's now only 49. So 36 times 35 over 50 times 49, 1260 over 2450, which reduces to 18 out of 35, or 51.4%. So for independent and dependent events, you guys really just have to figure out what the situation is asking for and pay attention to what is kind of happening. Just do it step by step. But for two events happening, we are going to multiply those items together.